Good morning or good afternoon. Today we're going to be looking at finding the roots and how that applies to real-world situations. All right, so the roots are the zeros of a quadratic. Those are the x-intercepts. So if you think about there being a graph and our parabola crossing, it's possible that we're going to have two roots. All right, now it's also possible that there could just be one root if the graph just barely touches it right at the vertex. And the third possibility for us is that we don't have any roots at all. The graph never touches the x-axis. All right, so those are our possibilities. We get one answer, two answers, or even zero answers. All right, so one way to do this, to find the roots, is to factor. All right, and again, the roots are essentially the x-intercept, so that means set the y equal to 0, because you want to be at ground level. And then we want to factor. So let's go ahead and try a sample problem. So let's do y equals x squared plus 7x plus 12. Let's look at that one. All right, and again, factoring works best when the a number is 1, and in this particular problem, the a number was 1. All right, so if I do that, what I'd be looking for are essentially two numbers that when I multiply them, I get 12. So here's a list of my choices. 1 times 12, 2 times 6, 3 times 4. Now the same pair must also add or subtract to make 7. So that's going to be the 3 and the 4. These other ones wouldn't work. Now when I add them, I'm supposed to get positive 7. And when you add and subtract, you always keep the sign from the bigger number. So the bigger number, which was 4, was positive. And then it's 4 plus 3 that would make 7, not 4 minus 3. So there's my two numbers for my factoring, but that's not the answer. I need these two things to multiply to make 0. And anytime you are multiplying two things together and the answer is 0, that means one of them is 0. It could be the first parenthesis that's the 0, or it could be the second parenthesis that's the 0. So if I solved this, I'd minus 3 on both sides. And if I solved the second one, I'd minus 4 on both sides. And you can see I'm getting two roots. All right, so two particular zeros are roots in this one. Right, now, that's not the only way to do it. Could have also done this using the quadratic equation. I could sing the song if you'd like, but I'm sure some of you would probably want to punch me in the face. All right, so if you don't remember the wonderful formula, so we're going to fill it in with x equals negative b. Well, b was a 7, so that means we're going to be putting in a negative of 7, all right? And then plus or minus, and then square root of b squared, and b was a 7, minus 4 times a times c. And a happened to be 1, and c was 12. Now the denominator is all over 2a, or 2 times 1. All right, so let's clean this up a little bit. There's a negative 7 in front. The denominator is 2 times 2. And then I want to do that whole messy square root portion. If I do all that square root portion there, I get 1. Now I'm going to get my two answers by doing both the plus and the minus. My first answer is going to come from me doing the plus version of this. All right, so I'm going to do the negative 7 plus 1 over 2. Now my second answer is going to come from me doing the minus version of this. So that means I'm going to get negative 6 over 2, which equals negative 3. This way I'd get negative 8 over 2, which equals negative 4. Those are the same two roots I got by factoring. Again, it's a little messier, but it always works, no matter what the situation. All right, so that might be a good plan of attack, is to use that quadratic equation if necessary. All right, so your work is going to look something like this today. And I know it's a little tiny bit blurry on the equation there, but I think we can still see it enough to know what's going on. It says the following equation represents the path of a donut hole being thrown by Mr. London, where x represents the time in seconds, the donut is in the air, and y represents the height and feet of the donut. So kind of a random thing, who throws donuts into the air, but whatever. I guess this guy wants to throw donuts. All right, so if it's me, I'm looking at this, and first off I see is I got an a that's negative 1, a b that's 4, and a c that's negative 2. So that's the first thing I notice. Now, because the a is negative 1, I know that this graph is going to be a downward pointing parabola. That's important to know. All right, let's go to the questions. At what time does the donut reach its maximum height? So think about this picture over here. The maximum height would be the top, and that's the vertex. So we're going to have to find the vertex. But to find the vertex, we have to first find the axis of symmetry, which is x equals negative b over 2a. So if we do that, that's negative 4 over 2 times negative 1, which is going to get us an answer of 2. So that means the axis of symmetry is over here at 2. Now, somewhere on that axis of symmetry is the vertex. And to find it, again, the vertex, we already know its x-coordinate, 2 something. We've got to find the y. So to do that, we go back to the actual equation and replace x with the number we just got, 2. So y equals negative of x squared. And it's important to put that negative outside the parentheses there. You'll get a wrong answer. Always put parentheses where the x was. Leave everything else alone. All right, so if you went ahead and did all of that, you would end up with an answer of 2. So that means that my vertex is at 2, 2, right here. All right, so at what time does the donut reach that height? Well, time is on the y-axis. That would have been this coordinate right here. And it's measured in seconds, I believe. So the answer to part A would be 2 seconds. That's when it happened. All right, now, what was that maximum height? Well, that's the x-coordinate of that vertex. How high up did this thing actually get? Well, it actually got all the way up to 2 feet. I can see that by scrolling over to the side there. All right, now the last question, this is the part we just worked on a few moments ago with the quadratic equation or factoring, is where does the donut hit the ground? So we want to know where does it land. All right, so to do that, we want to know its roots. So again, that would leave us with a chance of factoring, but the a is negative 1. That makes factoring hard. So I would have went ahead and done x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So the a number, sorry, that's the song from Algebra 1. It stuck in my head all the time. My a is negative 1, my c is negative 2, and all over 2a. All right, so again, if I do this, I'm going to get negative 4 plus or minus, and then that turns out to be square root 8. And the square root of 8 doesn't work out very nice. It ends up being around 2.8. All right, so I'll do one answer using the plus and one answer using the minus. The answer where I use the plus, I'm going to end up with an answer of 0.6. The answer that used the minus, I ended up with an answer of 3.4. So you can see that my roots were back here and around in here. So we want to know, when did the donut land? Well, the donut would have landed at that point right there. All right, so when does it hit the ground? That would be at 3.4 seconds. All right. Hopefully yours don't turn out quite so nasty as that one today. I think they're going to come out a little bit nicer, but this was a good example. All right, let me know if you need any help. Good luck.